In the previous section, we saw the need for a start winding, since the pulsating magnetic field produced by the run winding was unable to produce a starting torque to enable the rotor to self-start. In a typical single-phase stator, the run winding has more turns of thicker gauge wire than the start winding. This makes the run winding more inductive than resistive, resulting in the current in the run winding lagging behind the voltage applied to the winding. This can be shown in a vector diagram. We can see the number of degrees leading or lagging by connecting a phase measuring instrument to the winding under investigation. The start winding has less turns of thinner gauge wire, making it more resistive than inductive. As a result, the current in the start winding will tend to be more in phase with the voltage across the winding. The magnitude of the lag can be observed with a phasometer. With the addition of a suitable amount of capacitance in the start circuit, the current in the winding can be made to lead the voltage. These combined phase shifts make the current in the start winding lead the current in the run winding by approximately 90 degrees. Now, if the currents in the windings are displaced by 90 degrees, then so are the magnetic fields produced by these currents. As a result, a two-phase rotating magnetic field is produced that changes at the same rate as the supply frequency, which is usually 50 Hz. The rotating field system induces currents in the rotor bars that create magnetic poles on the rotor. These poles are attracted to the stator poles, which forces the rotor to follow the rotating magnetic field produced in the stator assembly. When the rotor reaches approximately 80% of its full speed, the start winding and start capacitor are no longer required, and the start circuit is disconnected by the centrifugal switch. Not all motors use a mechanically operated centrifugal switch. You may at some time encounter a voltage-operated switch, also known as a potential relay switch. Let's explain how it works. The switch is usually housed inside the terminal box. Within a protective casing, we find a simple voltage-operated relay with a set of switching contacts. The relay coil is connected in parallel across the start winding, and the switch in series with the start capacitor. When the motor reaches 80% of its rated speed, the additional voltage induced into the start winding by the rotor poles energizes the relay coil. The switch contacts open, disconnecting the start winding and capacitor from the main supply. After the break, we will overview two other types of capacitor induction motors.